Hello everyone, and welcome to lesson 6.3, which is on calculating slope. In our previous lesson, we talked about how slope was rise over run and how to count from one point to another to get what our slope is. Today's lesson is going to be an extension past that, and that is actually using a formula. That formula is written as m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, essentially, what we are measuring is the change that is happening vertically, up and down, on our y-axis, and we are measuring the change that is happening horizontally, left and right, on our x-axis. Sometimes you will see books have what's written in green. I'm going to highlight this in blue right here. You'll see this term that looks like triangle y divided by triangle x. That is really the Greek letter delta is what that triangle is. And basically that means change in, right? So if we can describe slope as rise over run, we can also describe it as the change that's happening on our y-axis and the change that is happening on our x-axis. So that's what slope really is. And now we have this formula, the y sub 2 minus y sub 1 over x sub 2 minus x sub 1 formula to help us calculate things. But that brings up some interesting pieces here. What is going on with all of these subscripts, right? Why do we have these? We haven't seen these before, really, in any of the lessons that we've done, and then mainly in math in general, we haven't covered a lot of those. What's the point? Well, if we think back to things that we've talked about in this section so far, or in this chapter so far, we know that in every point, the first number represents x and the second number represents y, right? So for my example problems, we can see that I have two x's and y's because I have 2 points. I have to be able to tell the difference between the points notationally, right? In my math notation, in my math formula, I have to be able to explain the exact position, the exact number that I'm talking about. So that way there's no confusion. The way that we do that is by putting in little ones behind the x and the y for the first point and little 2's behind the x and the y in the second point. That shows me what is grouped together, which one's my first point and which one's my second point. And now we have clear organization between the 2 points so we know which number is exactly which variable. So the whole point of those subscripts is just organization. It's just trying to keep things separated and organized so we know what numbers go with which point and where to put our values. So let's take a look at actually how to use our slope formula in practice. So if our slope formula is this m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, all we have to do is plug in our values. So I'm going to start by rewriting the formula. That's always a good first step. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And now we just have to plug in the values for each number. So if I look, the first thing that I have to deal with is y sub 2. Well, what number is y sub 2? Y sub 2 is 2. All right, cool. So there's 2. Then my next number that I have to deal with is y sub 1. Y sub 1 is -1, and I also see that I am subtracting y sub 1, so that means I am 2 minus negative 1. And now we do the same thing with the x's. Start with x sub 2. X sub 2 is 2. We're going to subtract x sub 1 and x sub 1 is 3. All right, so now I have my equation set up. I have all the numbers in the right spot. 2 minus negative 1, 2 minus 3. Now we just got to simplify. We know that two negatives together end up making a positive, so that's 2 plus 1. On the bottom, I still have 2 minus 3. And now we simplify one more time. 2 plus 1 is 3 for my numerator. 2 minus 3 is negative 1 on the bottom. So my slope is negative 3. Now, just as a quick side note, we did talk last section about how rise over run, we are going to call that our up and down motion over our right motion. So you can see here we got a negative 1 in our denominator. That's okay. Whenever you have fractions, not a lot of people talk about this, this is possible, but know that if I have the fraction 3 over negative 1, that's exactly the same thing as saying negative 3 over 1. It's also the same thing as just saying negative positive 3 over positive 1. I can put that negative wherever is most comfortable for me. So if you're watching this and you like having your negatives on top all the time, do that. If you're watching this and you have negatives out in front, that's totally fine. But just don't get too tied up at which number calculates out to being a negative. We can put it anywhere. So that should help us whenever we're calculating slope and figuring out what slope is. Okay, let's look at a couple examples for slope. Our first example that we have is 1, 3, and 0, 5. So we're expected to calculate the slope of this. Our first step is just going to be to label our points. So we have x1, y1, we have x2 and y2. We can go ahead and write out our formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then all we have to do is plug in our numbers. So that's going to end up being 5 for y sub 2, 3 for y sub 1, 0 for x sub 2, and 1 for x sub 1. Now, we don't have anything else to do here. We can just simplify the numerator. 5 minus 3 is 2. 0 minus 1 is negative 1. So our slope is just negative 2. All right. Problem number 2, it's going to work the same way. That's the great thing about slope. No matter what type of numbers we get, whether they're positive or negative, as long as we follow the same process, we're in great shape. So we start by labeling our points, x1, y1, x2, y2. And then we write our slope formula. Writing the slope formula is important because the more you write it, the more you will remember it. And you'll have that committed to memory. So if m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, all we have to do is plug in our values. Y sub 2 is negative 3. Y sub 1 is 7. X sub 2 is positive 3. X sub 1 is negative 2. Have a little bit of simplifying to do here, so negative 3 minus 7 over 3. Remember, two negatives make a positive. And that ends up giving me negative 10 over 5. And negative 10 over 5 reduces or simplifies to negative 2. Okay, so that is how we use our slope formula to calculate slope. Hopefully you found this lesson helpful. Hopefully you found the slope formula pretty straightforward to use. But if you've had any problems or had any trouble, as always, if you have any questions, please let me know.